Hi guys, so we're continuing with learning target 2C. This time we're talking about absolute value inequalities. Okay, so we're going to start off with some simple ones. We're going to consider the following absolute value inequalities. Okay, so here I'm actually going to go back to my toolbox since we already wrote this before, but this is to remind you. So absolute value inequalities, we have two types. The first type is where our absolute value is less than C. Okay. Our other one is where our absolute value is greater than C. Okay. When it is less than, right, a number, when our absolute value is less than, that is an and inequality. Okay. And something to help you remember, less than sounds like and. You hold a barbell in your hand. Okay. So your graph will look like this, like a barbell, right? Or a dumbbell, right? And you would split your equation like this, right? So this is an and inequality. On the left side, you have a negative C. On the right side, you have positive C. You have what you have in your absolute value in the middle, and you have your two less than symbols. Okay? When your absolute value is greater than something, it's going to be an or inequality. And how I remember it is greater sounds like or, greater sounds like oars of a boat, right? Boat, oars. Okay, and so that's why here our graph looks like oars, right? And how we split it is we take our absolute value and it's going to be less than negative C, or whatever this number here is, or it's going to be whatever we had in our absolute greater than C. Okay, so this is a great place to go to when you are stuck. Okay. So we'll start off nice and simple, right? Going back to our definition of absolute values and what it means, right? So absolute value here is talking about distance, right? So if you remember, we wrote this before as this, right? As our absolute value here, right? And this minus 0, there's no difference, right? If we simplified it, it would be x, right? So what this means, again, if you remember, is that the distance from, right? So absolute value is all about distance, right? So if you remember, this here is distance from, okay? In this case, distance from what? Okay, the distance from 0. What do we know about the distance from 0 that we're talking about here? The distance from 0 here is less than 3. Okay, so let's find 0. Okay. 0 is right here from the graph. Okay. So where is my distance less than 3? Okay, so if I count 1, 2, 3 away, and I count 1, 2, 3 away, everything from here to here has a distance less than 3 away from 0. Okay. What you would notice is 3, this is negative 3, right? And if we wrote it, right, so it'd be negative 3 less than x less than 3. So for the numbers, right, absolute value of x less than 3, that is all x values that are between negative 3 and 3. Because all the numbers in between here have a distance from 0 that is less than 3. Okay? So what about this? Right? So again, we could rewrite this as the absolute value of x minus 0 greater than 3. Okay. Again, this x minus here was talking about distance from. The distance from what? The distance from 0. And this time, we're talking about the distance from 0 that is greater than 3. Okay. So what x values, what numbers have a distance that is greater than 3. Okay? So here's 0. Okay. 1, 2, 3 away. On the left side, 1, 2, 3 away. Okay. And if you notice that anything beyond this has a distance from 0 that is greater than 3, right? So if you think about 4 is 1, 2, 3, 4 away from 0, right? Or if you think about negative 8 here, negative 8 has a distance greater than 3, right? So 1, 2, 3, 4, 5, 6, 7. It is 8 away. That is greater than 3. Okay? So one way to think about it is x less than negative 3 or x greater than 3. Right? So this just kind of is the concept behind how we solve for these absolute value inequalities, right? So here, let's solve this absolute value inequality. Okay, I have the absolute value of 5x minus 2 less than 3. Okay, so again, before we can separate our inequalities here, our absolute value has to be by itself. Okay, as you can see on the left side, it is by itself. So now let's separate it. Okay, so is it an and or an or? Okay, so here my absolute value is less than. Okay, so this is an and inequality, right? So my way of remembering it, right? If my absolute value is less than sounds like and, you hold a barbell in your hand, right? So that's how we split it. Okay. So I'm going to write how we split it. Okay. So we're going to take this and we're going to do the negative of it. So it'll be negative 3. Whatever we have in our absolute value goes in the middle. Okay. And then this becomes the positive, right? And note that when I rewrite it, the absolute value symbols are gone. Okay. After that, we know how to solve it. We are good to go. Okay, so I am going to draw my lines again just to help me. And I solve. Right, so I always want x by itself. Okay, so the first thing I'm going to do is get rid of this minus 2 by adding 2. What I do to one side, I have to do to all the others. Okay, so negative 3 plus 2 is negative 1. 5x. Negative 2 plus 2 is 0. Okay, so 5x plus 0 is just 5x. Okay, 3 plus 2 is 5. Because I didn't multiply or divide by a negative, my symbols stay the same. Okay. And then here, this is 5 times x. I want x by itself, so I'm going to get rid of this times 5 by dividing by 5. Okay, so this is negative 1/5. 5 divided by 5 is 1, so 1x. 5 divided by 5 is 1. Okay. And since I didn't multiply or divide by a negative number, my symbol stays the same. Okay. So that is my answer. Negative 1/5 is less than x is less than 1. And if I were to graph it, negative 1/5, 1, they are both open circles. And here I am shading what's in between. Right. Okay. So look, here's my barbell. Again, absolute value less than, that's an and inequality. Less than sounds like and, you hold a barbell in your hand. Okay. So let's do the next one. Okay. So here I have 3 times the absolute value of x plus 6 minus 8 is greater than or equal to 4. Okay. So first thing, before I split it up, figure out which type it is, I need my absolute value by itself. Okay. So as you can see here, it is being multiplied by 3, and it is also being subtracted by 8. Okay? So again, we're doing reverse order, so I need to get rid of this minus 8 by adding 8 to both sides. Okay. Negative 8 plus 8 is 0, right? So we don't need to write plus 0, because it doesn't change anything. And then 4 plus 8 is 12. Then, again, I still need the absolute value by itself. So since I have 3 times the absolute value, to get rid of the 3 times, I divide by 3. 3 divided by 3 is 1, so 1 times the absolute value just gives me the absolute value. 12 divided by 3 is 4. Now that my absolute value is by itself, I can split it up. Okay? So since my absolute value is greater than or equal to 4, greater, right? Greater sounds like or, so this is an or inequality. So how we split it up is we have what's in our absolute value. It's going to be less than the negative of this. And then the other one is going to be where we have what's in the absolute value. The x plus 6 is going to be greater than 4. Okay. How we split it up. So please be careful of the direction your signs are going. Okay. The less than one is going to go with the negative. The greater one is going to go with the positive. So then I solve. So subtract 6 to get x by itself. I have x plus 0, right? 6 minus 6 is 0, so x plus 0, which is just x, less than or equal to negative 4 minus 6 is negative 10. Then I'm going to do the next one. Okay, so again, I want x by itself, so to get rid of the plus 6, I do the opposite, the inverse, which is minus 6. 6 minus 6 is 0, so x plus 0, which is just x. 4 minus 6 is negative 2. Okay. So my final answer is x is less than or equal to negative 10, or x is greater than, oh, I forgot this, or equal to negative 2. Okay, and here's my final answer. I am going to graph it. So I have negative 10, negative 2. So x is less than or equal to negative 10. So closed circle going to the left. X greater than or equal to negative 2. So again, closed circle, and this time going to the right. See, so here's my or. This was an or inequality, right? So absolute value greater. Greater sounds like oars of a boat. Okay. And that's it for absolute value inequalities. Have a great rest of the day, guys. Bye.